Hey, this is Mark McDonald. I'm going to demonstrate to you my Pathfinder project, which is the final project for CSCI E89 Deep Learning class of Spring 2019 at the Harvard Extension School. Modern robots have developed in the recent past to be able to navigate over a wide variety of off-road type landscapes. No longer are robots restricted to flat surfaces or prescribed environments. And they can handle the ambiguity of things like rocks and cliffs, lakes, trees, and so forth. This project aims to provide these types of vehicles the ability to identify paths that are safe for them to navigate. Here are a few pictures of robots from Boston Dynamics that have proven an amazing ability to navigate and traverse difficult off-road landscapes. I'll be using a Mac with an external GPU. Data is downloaded from the indicated website. It's a large data set, 7 gigabytes. It was a project that explored the use of stereoscopic vision to navigate in off-road environments. The data set includes 6 training videos and 3 testing videos. I use a Jupyter notebook as the master notebook in this project. There are 3 support scripts for data processing, video support, and defining the model. User will create 2 directories. We'll move test and train data into those directories. Remaining directories are auto-created by the script. The downloaded data is a series of mat files, which is a dictionary of data. We're interested in 2 dictionary elements. One represents an image, the other represents a mask. We'll overlay the mask on the image to create superimposed images. When we have a trained model, we'll create the mask from our model and overlay that on images. One of the code challenges in this project was the small number of images. I chose to use augmentation to overcome this. The additional challenge here is that when we changed or augmented an image, we also needed to augment a mask exactly the same way. This problem was solved with a little bit of work, and we'll go through a quick demonstration. The master script, the Jupyter notebook first identifies your GPU environment, then walks through a few steps to set up the local directories, extract data from the downloaded data set into those local directories. The script will also create a demonstration of the manually created masks that show how the paths are highlighted and the obstacles are also identified. This is a perfect overlay, if you will. It was manually created, and there are 6 of these environments in our data set. Next, we'll train the model. It can take 30 to 60 minutes, and the result will be a video that will superimpose a mask onto a training sequence. So here we see the models working, but challenged. This environment is much more challenging than the ones it was trained on. We have harsh lighting conditions and a wide variety of obstacles. However, we see that the model here is identifying the hay bales as obstacles, and it is not identifying the sky as navigable. As we go around the corner here, we see again it's trying to identify the hay bales as obstacles. We go through the same scene again under less harsh lighting conditions. It looks overcast. Here we see that it's identifying the hay bale as it approaches it. Here, as we go around the corner, again, the hay bale is identified as an obstacle. General path is highlighted in front of us. The third environment is the easiest of 3 to navigate. It is a clearly delineated path with trees and bushes on the left and the right. The blob is clearly not random. It is identifying a path. Here it identifies an area to the right, but the video we're given moves to the left, and it immediately tracks to the area in the left. This works. Clearly proven concept. We might need to expand the model a little bit. We may need to tweak some of the variables, but we clearly have found something that works. Thank you for your time.